Detecting tin in soil samples. This year, I ran an experiment on how quickly plants could remove heavy metals from their soil. The first heavy metal that came to mind was lead. It's abundant, a serious issue, and has many tests to test the amount of lead in soil. But obviously, I couldn't use lead because I didn't want to get lead poisoning. So I had to find a substitute. When I looked to the periodic table, I figured out that tin was one row higher than lead, which means that it has similar properties, but it's much safer to use. However, when I tried to look for different ways to detect the tin in the soil, I couldn't find any, so I decided to make my own. Before I started anything, I made sure I had the correct attire. I had a lab apron, face shield, gloves, closed-toed shoes, and had my hair tied back. Although this attire is better to wear, it's also good to know that tin powder is much safer than lead. Although if the correct attire is not used, it can cause eye and skin irritation, and if ingested, it can cause GI irritation. I went through 3 different steps before I came to my final process. First, after adding 5 milliliters of the soil sample with tin and adding water, I expected the tin to form its own white thin layer. I expected it to separate from the soil on either the top or the bottom of the test tube. I shook the samples and waited a while. I even waited up to a day, but I didn't see any layer form, so I decided to try something new. Then I found that tin was paramagnetic. That means it's capable of forming weak attractions. So I used a neodymium magnet to try to attract the tin to the sides of the test tube. I held it around all sides of the test tube and even taped the magnet on and checked back in a day, but no particles attached to the magnet. Finally, I found a chemical reaction with tin. When tin combines with hydrochloric acid, it forms a salt-like substance. This led me to my final process. This is a diagram of it here. So the materials you need are your samples. In this case, it was my soil combined with my tin, test tubes, aluminum weigh boats, 1 milliliter graduated pipette, distilled water, and 1 molar hydrochloric acid. First, you add 8 milliliters of distilled water and 1 milliliter of hydrochloric acid to your samples. Next, you mass your aluminum weigh boats and record in your data table. Then you extract 0.7 milliliters of the supernatant, which is the clear liquid on top of the layer of soil, and put it in the aluminum weigh boats. This supernatant just has the water, hydrochloric acid, and the salt that formed from the combination of hydrochloric acid and tin. So therefore, once you bake the solution, all you'll have left is your salt. So you put the weigh boats in an incubator, an oven will also do, at 62 degrees Celsius for 24 hours. So the thing on the left, the picture on the left is before they were put in the incubator, and the middle and the right are after. As you can see in the middle, that's before the plants were added. So there's a lot of tin, as seen from the abundance of salt. But then on the right, there's not much salt in the aluminum weigh boats, which is proportional to less tin. This is the exact data. You can mass the weigh boats with their salt and subtract the mass of the weigh boats from earlier. That gets you just the mass of the salt. Then you can compare the results of your experiment. This invention is important as it's a safer way to model the use of heavy metals. Not only is it safer to use in place of lead and mercury, which can give things like lead poisoning, but it also opens up opportunities for younger scientists. They are free to run their own experiments with whatever they'd like and choose different inventions to try out with heavy metals without putting themselves in danger. Thank you for watching.